All right, we're ready to go. Yes, we are. All right, welcome to offline detection in Silverlight 3 and the .NET framework. While everyone's sitting down a little bit, my name is Peter Smith. I work in the .NET networking group. And something that everyone should know is if you go to the website, if you're watching like afterwards, after the MIX conference, if you go to the website and look at the PowerPoint slides, there's actually notes under each slide that gives more information than I can do in just a 20-minute talk. Let's just jump right in. Why are we doing offline detection? And why does anyone really care? Well, as some of you have probably heard by now, Silverlight now has the ability to run from the user's desktop, just like a normal application. They call that the offline mode. Now, there's a bunch of code and a bunch of APIs to actually do that detection of whether I'm on the desktop, I'm running from a website. But in addition to that, now all of a sudden, sometimes when you run, the user's not going to be online. They're not going to have access to your servers. If you want to pull down data and do something different depending on what that data is, depending on whether you're online or offline, well, all of a sudden, you might not be online. You have to detect that, and you got to do something about it. And I can give a quick example of a company I used to work for. Was a game publisher company. They had a client application, ran on the desktop, and it would do network detection. If you were online, it would download new catalogs of games. It would let you download new games and run them on your system. But if you were offline, it wouldn't do that because there's no point in showing you a bunch of games that you couldn't run anyway. But it would show you the games you'd already downloaded. That is, it made a clear distinction between what you could do online and offline. And some of you will now start to write Silverlight applications that want to do the same thing, that want to do a different user experience depending on online or offline. This talk is going to tell you how to do that. And the reason you need this is because it's actually a little harder than it sounds. It's easy to look at some of maybe the native APIs, if you look at native APIs, not that you have access to them, or some of the other APIs available to you, and you think, aha, network detection is easy. There's a Boolean that Microsoft provides. Why wouldn't I just use it? I mean, I want my application to be online or offline. It's a Boolean. Why can't Microsoft provide that? Well, we can't. The only way you can really know if you're online is, can you actually connect to your server? And have you validated the response? And not just the response code, because that's not good enough. You have to actually look at the data coming in and validate that that's your data. What Microsoft helps you with is it tells you when you can try again. And let's switch over to a demo. Let's hope it works. Hey, here we go. Here is a very simple Silverlight application. I wrote it. And you can tell I'm a programmer and not a designer because it's not such a nice. And you can tell there's some people in the woods here, and they're offline because they're in the middle of the woods. But that's all about to change because I'm about to put them online. And so I plugged the network cable in, and poof, all of a sudden, they're online. Someone built a cell phone tower, and now they're all online and they have their little netbooks out. Well, that's kind of cool, but this application actually does it wrong because this application, it knew it was online because it connected to this wire. And this wire goes to my hub right here. Where does this hub go? Well, this hub has this extra wire on it, but that wire doesn't go anywhere. We're sending packets out, and I can assure you that this is not a wireless connection. This is one of the things that makes offline detection hard. That program thought it was doing network detection, and it was. It could send packets out, but it's not doing really useful detection. It's not telling if that network that it's on is actually useful or not. But there's more problems than that with online-offline detection. The company I used to work for, holy cow, they spent a long time going through all of these issues. Is the network useful? That's the one we just hit. There's actually, occasionally you run into driver issues. It turns out that some operating systems, drivers, hardware, stuff you've done before, talk to me afterwards about a really cool case of that. It won't quite tell you if you're online or not, or connected or not. But wait, there's even other levels of problems going on here, one of which is the virtual PC problem. You might be running in a virtual PC session. They're very popular nowadays, especially for developers. But it turns out on at least one virtual PC kind of program, the virtual PC has a virtual Ethernet card, which is pretty cool, connected to a virtual cable. You can tell it's virtual because you can't see it. And it's connected to a virtual switch. And then the virtual PC program that's actually running on the real hardware is sending you network information on that virtual switch. But that means you're very isolated from the whole problem. which means your real network can be going up and down like crazy, and your program running on the virtual PC doesn't detect that at all. But wait, there's even more problems. There's even higher level problems. This is what I call the coffee shop problem. Lots of people take their notebooks, and I'm glad I didn't juggle any connections, into coffee shops, right? They turn on their Wi-Fi, and then you can actually, from Silverlight, send an HTTP web request off to your server. You'll get data back. It'll even say 200, OK. The problem is, it's all a lie. It didn't go to your server. It didn't pull down data. It all just stayed in the coffee shop. And the data you got back, it's a form from the coffee shop saying, oh, by the way, when you bought coffee, there's a little code on the receipt. You can type that in. Then we'll really turn the network on for you. These are all really big problems. But wait, there's an even bigger problem than that. Maybe you shouldn't connect at all. A lot of you have those little netbooks that are very popular nowadays. They come with little 3G cards, right? And some of those plans that you can get, you've actually got to pay by the kilobyte. Oh, holy cow. Sometimes, if you're doing international roaming, those charges are very substantial. You might be writing an application that downloads enough data where you expect people to roam, where you really, really, really don't want to connect unless the user has given you some sort of permission. And only you know that, of course. So once again, the one takeaway point, how do you know if you're online? Can I connect to my server and have I validated the response, not just the 200 OK? And once again, Microsoft helps you by telling you when to try. Let's take a look now at some of the APIs that we have and how you can use those APIs to actually do this detection. And here we see a VB.NET sample. I seem to be the only person doing VB.NET, which is weird because I do web searches. Lots of people use VB.NET. Yeah, VB.NET, very, very popular. And so we see up here on the screen two different functions. The first function says private sub on network change. This is a function you write. And this is going to get called when the network changes somehow. It takes in a couple of arguments on the by val s's object and by val a's event args. These don't have any useful information. And then the remark saying perform detection here. That's where you actually make a request to your server and validate the response. It'll be all asynchronous, of course. And the goal of doing that is for your application to eventually have a very simple Boolean, I am online or I am offline, so you can actually make a distinction in your user interface. Well, all right, so you've written this function, and you've done some detection code. This is all standard code, by the way. And actually, if you look on the MSDN site, in the regular .NET framework, I think there's some stuff on this. And actually, the NCL blog is also talking about this, too. And there'll be a pointer to that at the end of the slides. All right, so you have a function, big deal. You've got to actually get it called. That's what the public sub new is all about. This is going to be something set up by Visual Studio when your application loads, because this is what it does when you have an application load. I'm hoping to God, because I'm not really a VB.NET programmer. I just cut and paste from what it did for me. And in VB.NET, you can do an add handler. I'm pointing to my screen. That doesn't help you. Public sub new add handler, network information, .network change, .network address changed, and the address of on network change. On network change is that function you wrote before. And so what does this do? This hooks up your function into the .NET framework, and it'll call it on, I think, network address change. Why network address change? Well, it turns out that when you plug and unplug stuff, your network address changes. When you turn your Wi-Fi on and off, your network address changes. So that's a really good way for us to hook into something that will change when your network connectivity changes. So, whoop, that's the wrong one, that one. So I'm also going to show a C# sample because we do a lot of languages at Microsoft. This is the same thing. Because there's C#, you do a web search. There's actually about equal VB.NET and C#. This is the same code, only now it's C#. So it's an on-network change. Once again, function that you write. There's another comment in there. Only now it's called a comment and not a remark. Put network detection here. Public main page. And now the same kind of network handler, only it's C#. So the syntax is a little different. It's network changed, network address changed, plus equals new network address changed event handler on network change. Very simple, very straightforward. You'll get notified when things like plugging out and unplugging the cable happens. Something you need to know is it's kind of a noisy interface. So when you plug and unplug, a surprising number of things happen, and more importantly, more than one. And so you actually get several events in a row. Well, all right, so what have we seen? We've seen why online detection is hard. We've seen what Microsoft can do to help by telling you when something's happened. I've shown you some code that actually hooks up that information. Let's talk about patterns for your code. Why do we care about patterns? A code pattern is simply a way of organizing your code so you can be successful at doing the detection. It turns out there's some higher level patterns we can apply to network detection, and if you follow one of the patterns, you'll probably be successful. And more importantly, you need to decide which one or two of these patterns your code is going to do before you even start to write anything. And so there's 3 patterns that I know about. Anyone who has more, go to the NCL blog, type them in. And the 3 patterns are: 1, ask the user. Before you connect, validate. And constantly validate results. So it's ABC. The first one, ask the user, that sounds very manual, and it is. It means the user is going to actually tell you when stuff happens. The other 2 are automatic. Your code detects when something happens and does the transition automatically. Chances are that your code will probably use one of the automatic ones, and you should think about using the manual way in addition. So ask the user. In this code pattern, there's 2 buttons on your application, or checkboxes, or however you do it. One of them is retry. All of you probably noticed that every browser has a retry because everyone loves retry. A retry means that the user has some extra knowledge that you don't have that says you're probably connected to the network. For example, they typed in the little code from their coffee shop receipt, and so now they're pretty sure they're online. Or they got an email from the system administrator saying that they've fixed their connectivity problem. Or they've been told by their cable network provider that the cable outage is out. Right? The user has extra knowledge that you don't have. And the other is an offline mode button, and it prevents the application from even trying to get to the network. Second code pattern, and again, now we're switching to the automatic code patterns, is before you connect, validate. In this code pattern, you put a standard file up on your server. It's got an ordinary URL. All of your Silverlight apps can use the same file. You then download, when your application starts, you download and check the contents of the file. I personally like it to be an XML file, and I just check one section of it. Why? Because that way you can put other data into your XML file and share it across multiple Silverlight applications. But there's only one section that's actual, I am actually connected. All right, so you download it, you check it, and once you do that check, now you know, aha, I'm online. That implies, by the way, that when you started, the only thing you knew is you were offline. Did you connect to your server? No. Did you validate the results? No. You were offline. It's not until you do that check at the beginning that you know you're online. You have to revalidate on network change, of course, because that's the whole point of the network change. If you did the validation and it turns out you're offline, you get the network change, try it again. Maybe now you're online. There's also an interesting case, which is if you get a file from the server, but it's not your file, then you might have this sort of coffee shop problem. And now what do you do? The coffee shop isn't going to tell the computer anything that all of a sudden you have network connectivity. There's absolutely no signals that we necessarily get that will tell us anything. And so the only thing you can do is, if you're using a manual thing, is the user can click retry, or you can just automatically retry in however long you think is appropriate to do your retry. You might have an application that you really want to be online, and so you set the retry interval shorter. You might have an application where you don't want to swamp the network with fake requests because you don't want to do that, and you'd set it to longer. The last code pattern to look at is the constantly check results pattern. In this code pattern, you don't have a special file up on your server. Instead, when your application starts, you just say, hey, I'm probably online. And so whenever you need data, you just go off and you go get it. But then, when you actually get the data down, every single request you made up to your server to get data, you've got to validate to make sure it's really yours. If it's not really your data, now you must be offline. If you couldn't even get the data, then you're really offline. And once again, if you get a file from the server and it's not yours, then you probably have the coffee shop problem or some other problem. There's no guarantee you're in a coffee shop. And you just got to retry. The one takeaway point, as always, how do you know if you're online? Because you can connect to your server, and you have validated the response. And what Microsoft really does to help you is we tell you when to try again. And that's the most important thing I can tell you. And I'm delighted to say it's exactly 15 minutes. Thank you. If there's any questions, please ask questions. I got an email address. My team has the NCL team. It's a system, the .NET networking team. And we have a blog at blogs MSDN NCL. We're actually running a series on offline detection right now. And we also have a forum that you can ask questions on. Thank you very much. Oh, wait, before. There's an evaluation card. You all got to fill it in. And here's what you have to say. On the session code, this is session T78M, and the title is Offline Network Detection in Silverlight. The overall satisfaction with the speaker's presentation is very satisfied, and the usefulness is extremely useful. Thank you. So if there's any questions, please go to the microphone and ask the questions.
So just real quick, do you have any, is this on? Do you have any best practice suggestions for when, like if DNS is taking a long time to come back when you're, so you get a network event and you go to hit your server, but DNS takes a minute to time out. In that case, is the best practice to use a specific IP, but then you run into situations at a big company like Yahoo where we work where things are changing all the time. You just want to hit a domain that gets translated for you. So are there any practices there? And then the follow-on would be in the coffee shop issue, you know, how often should you re-ping? Since you're not getting another event, how often should you be re-pinging, you know, to see if your network has come back?
All right, so there's two questions. One is, what if I'm doing some network stuff and it's running really slow? And the specific question was, what if the DNS is slow? If the network is slow, it's slow. I mean, if it's not getting you an IP address, it's not getting you an IP address. I'm not sure I can give any more consolation than, sorry, but sometimes it's slow. And the other question is, well, what's the recommended time for rechecking? That's really application specific. And here's the basic parameters. Number one, the quicker you check, the faster you'll detect the online situation. The slower you check, the friendlier you are to the network. And it depends on, if you're a sociopath, you could check like every second. If you want to be really nice to your network administrator, you'll check every 10 minutes. If you want to be nice to your user, probably somewhere in between. I mean, no one's going to notice a 1 second versus, I hate to even give a number for being too specific, but I mean, we all know about how fast it should be. You know, I'm typing along, I don't know, 15 seconds? No, why not? Any more questions, please? None? Well, then thank you very much for coming, and I hope you enjoy the rest of MIX.